Welcome students. Let's continue with the naming of the rules for naming of the compounds, organic compounds containing double bond and triple bond. Okay. So in that, the first rule which we are going to talk here is we have to select the longest continuous chain containing the carbon atom involved in the multiple bond. It is compulsorily required to contain the carbon atom which is containing the multiple bond in the chain which we are containing here, which we are using here. So that particular uh, carbon atom can be containing multiple bonds such as double or triple bond. Okay, and on the basis of this only we will name this particular compound here. Second, we can use the suffix for double bond, that is in, and for the triple bond the suffix used it will be "-ine". Okay, so "-in" or "-ine" are the two suffix which can be used for double bond and the triple bond. Okay, now the third rule, the numbering of atoms in parent chain of atoms in parent chain is done in such a way that the carbon atom containing the carbon atom containing multiple bonds gets the lowest number. Okay, it gets the lowest number. Okay, so next rule, all the rules for nomenclature for organic compounds are followed here. Okay, all the rules which are used for naming the organic compounds are followed here in this particular naming of the compounds where we are using the double bond or triple bond also. Okay, so also if the multiple bond, okay, one more rule can be added out here. If multiple bonds occurs more than once, then prefix such as di, tri, tetra, etc. can be used. Can be used. Okay, so let's start naming some of the compounds. It will clear more of the doubts of you, and also it will explain the these rules very easily. Okay, so here I am taking an example for the CS3, CH2, CH2, C double bond, CH2, CH2, CS3. So here you can see that the longest chain will be 1, 2, 3, 4, 5, 6. But as a double bond is present here means a multiple bond is there. So in order to include this multiple bond in our root chain, what we will do, we will count out the chain from this carbon atom means 1, 2, 3, 4, 5. Rather, we will see that the longest chain here is this 6 carbon chain. But as a double bond is present here, then this 6 carbon chain will not be considered out here. This carbon atom, the first carbon atom will be this carbon atom, which will be containing this multiple bond, and the numbering or the lowest position will be provided to the multiple bond. So therefore I am starting the numbering from this carbon atom, and hence it has been given one number here. Okay, so according to this, how many carbon atoms are there in this particular compound? Five carbon atoms are there in the particular compound, but that particular chain is not the longest chain. Okay, due to inclusion of the due to the compulsory inclusion of the uh, carbon atom containing the double bond here is there. So therefore what we will do, we have to consider this chain which is containing only first five carbon atoms, not the chain which is containing the six carbon atom. Okay, now in this chain we will see that this particular two carbons, okay, these carbon atoms are acting as a substituent group. So then according to this, the name of the carbon, this particular organic compound will become 2-ethyl. In the prefix, the substituent group will come, and the substituent group here is ethyl. And five carbon chain, for five carbon chain, the word root or the alk name will be pent. And the bond name here, it is double bond. So for bond name, it will be ene. So the name of this compound will be 2-ethyl ethene. 2-ethyl pentene. Okay, 2-ethyl pentene. Similarly, if we are taking one more example, that is CH3 CH double bond CH CH2 CH2 CH3. So here the numbering of the compound can be done from both the sides, that is from the right hand side also, from the left hand side also. When we are numbering from the left hand side, the position provided to the multiple bond here is, it is second position, while when we are numbering it from the right hand side, the number provided, the lowest number which is provided to the multiple bond, it is 4. So here the lowest locant rule will be applied, and the lowest position will be provided to the preference group, that is the multiple bond here, and hence the numbering will be considered here from the right left hand side one, and the name of this compound will become 6 carbon atom. For 6 carbon atom, the alk name will be hex, as the double bond is present in the second carbon. So here we will use the position, that is 2, and double bond is there. So for double bond, the suffix which is used, it is in. So the name of this compound will become hex 2 in. Okay. Let's take one more example. CS3 CH2 C triple bond CH. Okay. So here in this compound, what we will do here, the carbon atoms are 1, 2, sorry, numbering I'm doing wrong, because we have to provide the lowest number to the triple bond. So triple bond's lowest number can be provided by the right hand side carbon atom. Four carbon atoms are there, so here the name will be starting from the but. The alk name will be but. In the first position only, the triple bond is there, so but 1 ine. Okay, but 1 ine will be the name of this compound. Okay. One more example we can take, CH2 double bond CH double bond CH2. Okay, so here we can start either the numbering from the right hand side or either the numbering from the left hand side. Okay, here in this case, the symmetrical symmetrical nature is there in this compound, so we can start the numbering from either side, and on the both the cases we will find the same locant positions here. Okay, so now the name of this compound will become but. In the first and the fourth location, we are having a multiple bond. So 1 comma 4, and as two multiple bonds are there, the double bonds are containing in 2 in number. So therefore we will add a suffix, the prefix, that is di, and the suffix for the double bond, it is in. So the name of this compound will become but 1,4-diene. Okay, 1,4-diene. Okay, 1,4-diene. Next, one more example we can take here. CS3, CH, CS3, C, double bond, CH2, CH2, CH3. Okay, here we have to include the double bond in our chain. Okay, in the root chain the double bond must be included, and also the chain which we are going to consider, it must contain the largest number of the substituent groups. Okay, so here when we are taking the chain 1 2 3 4, okay, only one substituent group will be there, which is this one. But when we are taking the chain, that is 1 2 3 4, this chain in which 4 carbon atoms are there, so two substituent groups are there. So out of the two chains which are containing same number of carbon atom, that is 1 2 3 4 here also, and 1 2 3 4, 4 carbon in the straight long chain, and 4 carbon atoms in this L shaped chain. Okay, so in both these conditions we will see that in the L shaped chain only one substituent group is there. So we will not consider the L chain, we will consider the straight carbon chain where two substituent groups are there, and according to this the naming of this compound will become for the two substituent groups in the second position, as this is ethyl one and this is the methyl group. Okay, in the second position ethyl is there, and on the third position methyl is there. So the naming of this compound will become, according to the alphabetic order, 2 ethyl, 2 ethyl, 3 methyl, 2 ethyl, 3 methyl, and for 4 carbon atom but 1 ene. Okay, but 1 ene. This will be the name of the compound which has been given out here. Let's take one more example. CS3, CH2, C, CS3, CH2, CS3, CH2, C, triple bond CH. Okay, so here in this compound, first we have to choose the longest chain. Okay, so the longest chain will be the chain which is containing the multiple bonds. So 1 2 3 4 5 6, or 1 2 3 4 5 6. Okay, in both the cases the 6 carbon atoms are there, and in both the cases we will see that two substituent chains are there. So any one of the chain can be considered out here. So I am taking the longest straight chain. Okay, the straight chain I am taking as the root chain here. So 6 carbon atoms are present in our root chain, and in the fourth position a methyl group is attached, and a ethyl group is attached. So the name of this compound will become 4-ethyl, 4-ethyl, 4-methyl hex 1-ine. Okay, 4-ethyl, 4-methyl hex 1-ine. So the name of this compound will become this. Next, CS3, CH, CS3, C, triple bond CH. Okay, so here the chain is 1 2 3 4. At the third position a methyl group is attached, 3 methyl. The name of this compound will become but 1 ine. Okay, next CS3, C, CS3, CS3, CH, CS3, CH, double bond CH, CS3. Okay, so here the longest chain can be 1 2 3 4 5, 1 2 3 4 5 6. Okay, so this is the longest chain, 1 2 3 4 5 and 6. And here three substituent groups are there at fourth position and at fifth position 2. So here the name of this compound will become 4 comma 5 comma 5, and all the substituent groups are methyl, so the name will be For 3 methyls it will be trimethyl, and the name of this compound will become hex 2 hex 2 okay, 4,5,5 trimethyl hex 2 So this way are the rules for naming the double bond and triple bond. Now we will continue further with the rules for naming the organic compound containing the functional groups. Okay. So in this particular, when we are going to name the organic compound which is containing the functional group, the first rule is that select the longest continuous chain containing carbon atom containing carbon atom joined to or attached to the functional group. Okay, attached to the functional group. So here the first thing is that we have to choose the longest continuous chain with the carbon atom which is attached to the functional group. The next is the functional group, the carbon atom containing containing functional group must be provided with lowest number must be provided with lowest number. Okay. Third, all the rules which are used for the all the rules for side chain and substituent groups are applicable. Okay. Next, so here these are the three rules which we are going to follow for the naming the compounds which are containing the functional group. Okay. So the functional group, you are knowing that the functional groups which will be used out here, it can be alcohol, it can be aldehydes, it can be ketones, carboxylic acids. Okay, like this the difference can be used out here. So here, taking one example, we will start the naming of this type of compounds. So here CS3, CH2, CH, CH2, CH2, CH3. So this is a compound which is containing a functional group here. So here, if I am attaching one more carbon here, okay, like this. So here the chain will be this chain. So here the longest chain will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So the longest chain will be this one. And in this particular chain, what we have to do, we have to provide the lowest number to the OH group, which is the functional group here. Okay. First rule was that to choose the longest chain continuous carbon atom chain which is containing the functional group, and second is the numbering should be lowest to the functional group containing carbon atom. So here the lowest number can be provided when we are numbering the chain from the left hand side. Okay, from the left hand side. If you are numbering the chain from the right hand side, then the number which is provided to the carbon atom which is containing the functional group, it will increase out here. So in order to deny this thing, what we will do, we will number the chain from the left hand side, and the number which is provided to the carbon atom which is containing the OH group here, that is the alcohol group here, it will become 3. Now the name of this compound will become according to this particular rule, as the third group is containing a substituent group, that is the methyl group here. So the name will start from the substituent group, that is 3-methyl. Then for 6 carbon atom, hex and all the bonds which are present here, they all are single bonds between the carbon carbon atom, so it will be ane. And as third position is containing the alcohol group, so the name of this compound will become 3 methyl hexane 1 hexane 3 all. Okay, 3 methyl hexane 3 all. Let's take one more example and clear out this particular naming process. OH CS3 CS3. Okay, a compound which is given like this. So here what we will do, we will first find out the longest chain. So the longest chain can be 1 2 3 carbon atom chain which is containing the OH group, that is the alcohol group here. And in this particular chain, substituent group of methyl is present, so the name of this compound will become 2 methyl. For 3 carbon it is pro, and for the single bonds in the second position the alcohol is attached, so for the alcohol the suffix is ol and the name will become 2 methyl propane 2 all. Similarly, if we are adding some other functional group, that is if we are using a ketone here, ch2 c double bond o ch2 ch3. Okay, here we can see that C double bond O, okay, R C double bond O R. This particular compounds are termed as ketones. So for ketones, ONE is the suffix which is used. Okay, so numbering for finding out the longest chain. So for finding out the longest chain, 1 2 3, the numbering we will start from the right hand side in order to give the smallest number to the carbon atom. So 1 2 3 4 5 6, 6 carbon atoms longest chain is here, and in that the functional group is also included. Now the fifth carbon atom is containing a substituent group which is methyl. Then the next will be given the alk name. The alk name here is hex, and here the third sorry, all the carbon atoms are attached with each other with a single bond, no double bond is there, so the bond name here it will include as ane. And at the third position the ketone is been attached, so hence the name will become 5 methyl hexane 3 on, 5 methyl hexane 3 on. Okay, next cs3c cs3 ch2 cs3 ch ch2 cs3 choh ch2 cs3. Okay, so in this type of compound we will see that the longest chain, which one is the longest chain? So 1 2 3 4 5 6, 1 2 3 4 5 6. Okay, so here we can see that the longest chain which we are taking here, it will be the 1 2 3 4 5 6 7. This one will be the longest chain. 3 4 5 6 7. Why? Because it is containing the most number of substituent groups here, 1 1 2 3. Okay, so here how we will name this particular compound? Here the naming of this compound will start like this. First we will give the position for the ethyl, so 5 ethyl. Then for the methyls, so methyls are present at fifth position, and that is also 2 in number, so 5 comma sorry 1 2 3 4. Oh, sorry. 4 ethyl it will be, not 5 ethyl, it is 4 ethyl. Okay, 4 ethyl, 5 comma 5 dimethyl, 5 comma 5 dimethyl, dimethyl. To this 7 carbon atom chain, that is hept in 3 all is been attached. So the name of this compound will become 4 methyl 5 comma 5 dimethyl heptane 3 all. Okay. Similarly, we can take one more example. CS3, CH2, CH, CH2, CS3, CH2, CHO. Okay, 1 2 3 4 5, 1 2 3 4 5. So the carbon atom which is containing the LD, that is the functional group here, this will be the longest chain which will be containing the functional group, and the name of this compound will become 3 ethyl 3 ethyl, okay, 3 ethyl, and for 5 carbon atom, pentane, pentane 1 al, pentane 1 al or pentanal. Okay, you can use directly pentanal here because as the carbonyl groups, okay, the carbonyl groups are what? The carbonyl groups are this one, the compound containing which are containing the C double bond O bond. Okay, so they are termed as the carbonyl compounds or carbonyl functional groups. So carbonyl functional groups are generally termed as the, they are generally termed as the terminating groups also. Okay, terminating functional groups also, because they generally ends or starts the chain. Okay, they generally ends or starts the chain, so therefore there we can deny the position, okay, in that particular naming process in the carbonyl groups, but in other functional groups we have to use the compound name there. Okay, some more example we can take here, such as we can use one more example, that is cs3 ch2 ch cs3 COOH. So here the chain will start from this carbon only. 1, 2, 3, 4. Okay. This will be the chain which will be included in our chain, and here the name will become 2-methyl 4 carbon bute for COOH single bond in, and for COOH, that is the carboxylic acid, oic acid is the suffix which is used, and the name of the compound will become 2-methyl butanoic acid. Okay. Next, CS3, CH2, CH2, CN. Okay. So here also the numbering will be start from the carbon atom which is in the functional group only. 1, 2, 3, 4. Okay. Here the name of this compound will become butane nitrile or butane cyanide. Okay. Butane nitrile or butane cyanide. Similarly, if more than two functional groups are there, we are now taking the examples of the carbon of the organic compound which are containing more than two functional groups. Then how to name them? Okay, how to name them? So here we are taking an example for the functional group of ester and that of the halo one. Okay, so here the compound chain will start from the carbon atom 1, 2, 3 and 4. Why? Because this is the functional group here, and here the chain will start, and the longest chain here is of the 4 carbon atom. So the chain will be of 4 carbon atom, which is containing a substituent group which is Br here, bromo, and a substituent chain is been attached here, which is the oxyethyl group. Okay, oxyethyl group. So here the name of this compound will become ethyl, ethyl, or one ethyl you can also use, but ethyl, ethyl, one sorry, 2 bromo, 2 bromo butanoate, 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 noate, OATE. It is the butane, then OATE. OATE is the suffix which is used for the esters. Okay, it is a suffix which is used for the esters. One more example we can take, CH2, 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 COOH. 1, 2, 3, 4. Okay. So here the name of this compound will become 4 iodo, as halo are been considered as the yeah, they are always, the halo compounds are always included, halo function group are always included in the prefix only. So the name of this compound will become 4 iodo butanoic acid. 4 iodo butanoic acid. Okay. Let's take some more examples. CS3, C double bond O, CH2, 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 Cl. Okay. So here the name of this compound, the longest chain 1, 2, 3, 4. 4 chloro sorry, methyl, okay, methyl, sorry, no methyl will be there, sorry, it is a ketone group, so the numbering will be start from the last carbon atom only. I have given the wrong numbering here. The numbering will start from the last carbon atom only, that is this one. 1 2 3 4 5. Okay, all because they all are connected through carbon atoms only, so the chain will be from the last carbon atom only. 1 2 3 4 5. So 5 chloro, the name of this compound will start from 5 chloro pentane on 5 chloro pentane 2 on, sorry, pentane 2 on, because at the second position the ketone group is there, so pentane 2 on. Okay. Next, ch3 ch cl ch2 ch2 co nh2, or it can be also represented like this: c double bond o nh2. Okay, so here the numbering will be start from the carbonyl group only. 5 carbon atoms where fourth is containing the chloro group. Then for the 5 carbon atom, pentane amide, CONH2, it is the amide, so the name of this compound will become pentane amide. Next, for the compounds which are containing same functional groups but more in number, okay, more than one in number, then this type of compounds will be termed as 1 2 3 propane 1 comma 3 diol, di tri tetra penta all can be used out here. Okay, similarly ch2 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 cho 1 2 3 4 5 pentane 1 comma 5 diol, pentane diol. Okay, pentane 1 comma 5 diol. Here we can use e, here we can use e because the d is there, which is not a vowel, so two vowels cannot be simultaneously used, but one vowel and one d, as d is a consonant, so here we can use the e here. So here also in the propane also e can be included, and the name will be propane, propane 1,3 diol, pentane 1,5 diol. Okay, similarly for 2 carboxylic acid also, ch2 ch2 COOH. So here 4 carbon atoms, 1 2 3 4, and for 4 carbon atoms butane 1 comma 4 dioic acid. Okay, butane 1 comma 4 dioic acid, or you can directly use, that is butanoic acid, butane dioic acid. Okay, so these are some of the rules by using which you can name compounds which are containing functional groups. Now, if with the functional groups double bond are also there or triple bond are also there, then we will use the preference order, that is functional group will be given first preference, then the double bond will be given the preference, then the triple bond will be given the preference, and at last the substitute or the side chains will be given the preference. Okay, it means that the first preference will be given to the functional group, then the double bond, then the triple bond, then the side chain will be provided. So for this, let's take an example: cs3 ch ch2 oh. Okay, so here as we can see that our functional group is also there and a double bond is also there. So here the numbering will start from the functional group only, and the name of this compound will become but 2 in one all. Okay, but 2 in 1 all. CH3, CH double bond, CH, CH2, CHO. So here also the numbering will start from the functional group chain or functional group carbon only, and the name of this compound will become pent 3 in 1 all. Okay. Now if a double bond is there and a substituent group is also attached or side chain is also present and a functional group is also there, then the chain will be the longest chain which is continuous and containing the double bond also and the functional group also. Okay, both will be continued out there, and the side chain will be this one. So the name of this compound will become 2-methyl hex 3 in 1 all. Hex 3 in 1 all. Okay, so these are the naming rules for the compounds. Okay, so these are the compounds which are containing double bond, triple bond with the functional groups. Okay, now if more than one functional group are present there, so then the preference which we are going to use here is carboxylic acid is the most preferential. Okay, after that comes the sulfonic acids. Okay, sulfonic acids means SO3H. Carboxylic acids means COOH. Then after that, acid anhydrides, that is COOCO. Okay. Then esters comes, that is COOR. Then acid halides come, acid halides, that is COCl. Okay, or COX, we can use COX also in the place of X. Chlorofluorobromine, anyone can be there, COX, where X can be chloro, fluoro, bromo, or iodo. Okay, chlorofluoro, bromo, or iodo. Then next, oh sorry, here it will be X on, here it will not be X, it will be chlorine only. Okay, it will be chlorine only. Acid halides are generally chlorides only, COCl, COCl. Then next, amides will be there, that is CONH2. Then next, nitriles will be there, that is C triple bond N. Okay, or cyanides, they are also termed as cyanides. Then the next position is given to the aldehydes, that is CHO. The next position is given to the ketones, that is C double bond O. The next position is given to alcohols, OH. The next are the amines, NH2. The next are the ethers. The least preferentials are the ethers, ROR, ROR. Okay, they are the ethers. Okay, and all the remaining groups such as the halo, then the nitroso, in the halo, fluoro, chloro, bromo, iodo. Okay, in the nitroso, NO, then the nitro groups comes, that is NO2. Then the alkoxy groups comes, that is OR. Okay, they all are being termed as the substituent groups. Okay, and also the alkyl groups, they all will be termed as the substituent groups only. Okay, so here if you are taking example, that is CS3 CH2, 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 COOH, and here I am attaching a one more functional group here, that is OH. Then the preference will be given to carboxylic acid. As we can see that in the preference list, carboxylic acid is more preferential than the alcohols. Okay, than the alcohols. Where is alcohols? Alcohols is here, and carboxylic acid is in the first position. So hence the first position will be provided to the first preference will be provided to the carboxylic acid, and the OH will be termed as the substituent chain here, substituent functional group, and it will be given the prefix position here. So according to this, the name of this compound will become 4 hydroxy 4 hydroxy pentanoic acid. 4 hydroxy pentanoic acid. For different functional groups which are being used as prefix, I will be giving you some examples in which I will be telling you their prefix name also. Okay. For example, CS3, C double bond O, CH2, COOH. So here ketone is less preferential as comparison to that of the carboxylic acid. So it will be termed as the substituent functional group, and hence the name of this compound will become 3-oxo, which is the um, prefix name for that of the ketones, 3-oxo butanoic acid. One more example, CS3, CH, NH2, CH2, CH, CS3, and a OH group is attached out here. So here we know that OH is having more preferential as comparison to that of the NH2 group. So here the principal functional group will become the alcohol. So the naming will be 1, 2, 3, 4, 5. For the fourth position, it is the amino group. So the name will be 4-amino pentane 2 all. Okay, the name of this compound will be 4-amino. Amino is the prefix name for that of the amines, and the name will be 4-amino pentane 2 all. Next, CS3, C double bond O, CH2, CHO. Here aldehydes are more preferential as comparison to that of the ketone. So for the ketones, the prefix name is oxo butane 1 all, butanol, oxo 3-oxo butanol. Okay. Next, CS3, C double bond O, CH2, CH2, OH. Here the carboxyl group, okay, that is the ketone group is more preferential as comparison to that of the alcohol. So the numbering will start from the left hand side, 3, 4, 4 hydroxy, 4 hydroxy butanone, butane 2 on. Okay. So according to the preference list, we have to find out which one is the more preferential here. Okay, which one is the more preferential? CH2, CH2, CHO. So here, if we are comparing the cyanide group with the aldehyde group, so cyanides are more preferential as comparison to that of the aldehyde. So here, the naming of this compound will be 1, 2, 3, 4. So 4, 4 for aldehyde, formyl is being used. Okay, for aldehyde, 4 formyl, 4 formyl, for 4 carbon atoms, butane nitrile, butane nitrile. This will be the name of this compound. Okay. Similarly, if with nitrile, that is the cyano group, if more preferential group such as COOH is being attached, so then the name of this compound will become, sorry, this particular carbon atom will not be concluded in the chain. So here also it will not be concluded in the chain. So the compound's name will be changed out here. It will be 3-formyl. Here it will be 3-cyano. The cyano is the prefix name. 3-cyano propanoic acid. Propanoic acid. Okay. So like this, we can name the compounds on the base of the functional group which is been attached out there. Okay. If more than one functional group is attached, then we will use the preferential list. Okay, preferential list which I have given you in the previous part of the video. From there you can copy it down and you can make it by heart, so it will be easy for you to name the compounds which are containing more than one functional groups. Here we can use we can name this compound like this: 1, 2, 3, 4. More preference is provided to the ketone group as comparison to that of the alcohols and that of the methyl group here. So the name of this compound will become 3 hydroxy. Okay, hydroxy. Then 3 methyl. Then comes the 4 carbon, that is butane 2 one. Okay, butane 2 one. So like this we are going to name the carbon chain which is containing the substituted side chain to two different uh, function groups also. Okay, so these were the different rules for naming the organic compounds which are containing function groups with them. So for today's class I am ending the class here only. We will continue with the next topic for this chapter, that is the naming of the aromatic compounds, and after that we will continue with the isomerism, very important topic of this particular chapter. So thank you for today. We will continue in the next class.